Here we're going to look at learning objectives A and B. I'm going to show you how to write logarithms as exponents and evaluate them. And then we'll also find logarithms of base 10 numbers. So the first thing you need to remember is from Algebra 2x, they showed you that if you had a logarithm like this, you could rewrite it in exponential form. Because logarithms, when people see these, they get nervous and think they're going to be difficult. All logarithms is truly exponents, and you just have to figure out how to convert them. So notice the conversion they're doing. Here's how you take a log and write it as a base. This is called log base b of x is how you say it. So this is log base b. Well, this is the base of the log. This is also called the base of the exponent. So all you have to do is start at the base of the log, and you're going to rewrite that the same. The next way you go is you notice here they put the y, which is across the equals to. So cross over the equals to and make that y its exponent. And then you're going to notice they set that equal to the x value, which was back over here. So what I like to do is call this a swoosh. I start at the log base b and I swoosh over to both sides and I rewrite it. So what I did is it's log base b is exponent base b of y equals x, which will give me that. So let me show you how it works with something that turns out quite nicely. This is how we say this. Log base 3 of 9 equals 2. And all I have to do to really understand this logarithm is make it its exponent partner. So I start with the base of the log, which in turn is just the base of the exponent. And then I swoosh across. So what I do is I say it's 3 to the power of 2 equals 9. And that is how you interpret a logarithm, but in its exponential mode. Now the question here on this side, they're saying it a little bit differently. Which one do you think matches up properly? Which statement is read? P is the log of Q to the base S. Well, if the base is S, that has to be this little base right there. So it actually ends up being letter D. But let's look and see why. Because it says P is the log of Q to base S. So there's a different way you can actually say it. Okay, so let's evaluate a variety of logs. Letter A here says the log of 512 to base 8. Let's first write it. The log of 512 to base 8. Now, if we write that as an exponent, here's what I'm going to say. It equals something. I'm going to put a question mark. And all I'm going to do is take the logarithm, I go to the base of the log, and it becomes the base of my exponent. So I say it's 8 to some power equals this. So 8 to some power equals 512. Now I might get my calculator out to figure out what that is. It actually ends up being the number 3. Okay, let's look at letter B. This just says log base 8 of 164. I'm going to put this equals something. So I'm not sure what that exactly it means, so let's rewrite this as a exponent. So if it's log base 8, it's exponent base 8. So it's 8 to some power equals 1 over 64. This one has a little bit of a twist to it. A good thing to first look at is notice the number 64 here. So what do they do? 8 to what power is 64? Well, 8 squared. So we're thinking the answer should be a 2 up here, but 8 squared is 64. They have 64 in the bottom. How did they get it to the bottom? They made it negative. So remember, 8 to the negative 2 power would mean bring it down and would be 1 over 64. So the answer to this, log base 8 of 164 equals the number negative 2. Okay, this last one, we have log base 8 of the 7th root of 8 equals something. So I'm just going to say equals something. And again, let's just rewrite this logarithm as an exponent. So it's log base 8, so I'm going to say exponent base 8, and then I'm going to do my swoosh. So 8 to some power equals this. Okay, they need to match up. Both sides need to look identical. So I'm going to take this and take the radical and just make it look like an exponent. So 8 to some power is equal to 8 to the 1/7 power. Well, for these two sides to match, this question mark has to actually equal the number 1/7. So that's our answer. Let's look at these three more for extra practice. Log of 625 to the base 5. So I'm going to say log base 5 of 625 equals something. And if I rewrite it as an exponent, the real question is 5 to some power equals 625. Again, I may not know this offhand, but if you play around in your calculator, you're going to realize the answer here is 3. Part B. Log base 4 of 2 equals something. Again, let's take log base 4, let's do 4 to that power equals this. So 4 to some power equals 2. Now notice this, 4 got smaller. The only way to make 4 smaller is not to use the power of an integer, but of a fraction. So the fraction they're doing here is a 1/2. They're taking 4 to the 1/2 power, which equals 2. So the answer, again, is what the exponent was, is 1/2. And then the last one here, log base 6 of this value equals something else. So I'm going to do that. We're going to do log base 6, and let's rewrite it. So 6 to some power equals 36 to the negative 1.5 power. Now this one's a little tricky too. Here's the problem. As it stands, we can't compare them because they're two different base numbers. We have to make the base numbers the same thing. Now, is there a way I could make a 36 look like a 6? Sure. How about 6 squared? So if you do 6 squared, make sure you keep the other part, is raised to this power here. Let's just simplify. 6 to some power, I don't know what. And on this case, remember the exponents we multiply, so it'd be 6 to the negative 3. So clearly for these two sides to match, my question mark has to be negative 3. So the answer to this problem is negative 3. Let's try this one. Evaluate log base 9 of 3. Okay, this is going to equal something. I'm going to call it x this time. And I'm going to take the base of the log and just rewrite it as its exponent. So it's 9 to some power equals 3. Again, as it stands, these are not comparable because they're different base numbers, but you actually can write 9 as a base 3 number. It's 3 squared, and there's an x on the outside, and this is 3. So when you multiply, you have 3 to the 2x power equals 3. So now the problem is we're trying to solve for x, and we need these two sides to be identical. The only thing we know is because the bases are the same, that those exponents should be the same. Well, what is this exponent? You don't see it, but it's a 1. So what you can do here is in order to figure out what is going to make these two exponents the same, this is an exponent of 1, and this has to equal 1. So my brain says this x value is probably 1/2. Here's all you have to do. Take these two values and set them equal to each other. So I'm going to set the exponents equal to each other. I'm going to divide by 2. Therefore, I know x has to be 1/2. Because the initial question was, what is x? It's not that the value was 2x. So be careful on that one. Double check your answer. 9 to the 1/2 power? Sure, it does equal 3, because that just means take the square root. Let's continue on. Here we have log base 4 of 8 equals something. And again, let's just use, we'll use the letter D this time. Just mix it up. So I'm going to do exponent base 4 of D is 8. So 4 to the D power equals 8. Again, the bases are not the same. How can I make them either both a 4 or an 8? Well, you can't, but you can make them both a 2. So why don't we come in here and say 4 is 2 squared, and that's a D, and 8 is just 2 cubed. So therefore we have 2 to the 2D power equals 2 cubed. Well, the base numbers are identical right now, the 2 and the 2. For these both sides to look identical, this exponent has to equal that exponent. So that's all you have to do. You have to come over here and say, fine, I'm going to make the one exponent equal to the other. Just do the algebra to see what D is in this case. The answer here is 3/2. So if you take 4 to the 3/2 power, you will get the answer of 8. Here's another one. log base 125 of 25 equals, I'm going to do question mark this time again. I'm going to rewrite it with my swoosh. So 125 to some power equals 25. Well, I can't write this as 25 as a base number, but I can write it as a 5. That's 5 cubed, and then I have my question mark. Well, 25 is 5 squared. So in this case, again, I need these exponents to match up. So I need the 3, and maybe if we don't want question mark, but you want to put x there instead, if you prefer a variable, solve for x. So x in this case is going to be 2/3. And that's what this would be here, really, I guess, for our question mark. 125 to the 2/3 power would equal 25. So 2/3 is the answer. Now it's going to be important for us to talk about base 10 because when you look at your calculator, there's a button that says log. That button on your calculator that looks like log is base 10 counting. And what they don't normally write is this. This says log base 10 of 100. How you would normally see this is log of 100. They do not put a base 10 number if it's implied that it's our counting system. And it's considered our counting system because here's how our counting system changes by tens. That first counting number position is the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you hit 10, you create a second place. And so that's how we count is by tens. So be really careful when you see this because you won't see the 10. If you see a number like this, you're more than welcome to write the little 10 in there. Well, let's evaluate it because that's what letter A is saying. Find the log of each of these base ones. Letter A says log base 10 of 100. Again, that's how they would write it, but feel free to put the little 10 in there and do it equals x. If you rewrite this, 10 to some power equals 100. Well, that's easy. The answer is 2. Let's look at letter B. Letter B, they want you to find log base 10. Again, they're not going to put that. And we say this, not tenths, hundreds, thousandths, 10 thousandths. This is going to be 100 thousandths. Is what? So again, you might want to put the little 10 in there to help you see it better. And if you rewrite it, it's going to be 10 to some power equals 0.00001. Well, this side has to be a 10. So what do you have to do to this decimal place? You have to move it 1, 2, 3, 4, 5. I'm going to have to go 6 places to make it look like a 10. So be careful. Is this 10 to the 6th power? It's 10 to the negative 6th power. So the answer here is negative 6. I'm going to skip letter C and just go right to D. So D is log base 10 of 10 to the square root of 10. Again, let's put the little 10 in there because they don't, and rewrite it. So to rewrite it, it's 10 to this power equals that. So 10 to some power equals 10 to the square root of 10. Now this one's a little tricky in that they have 2 10s here. What I'm going to do is rewrite this radical symbol as an exponent. Let me just do this. 10 to the x is 10 times 10 to the 1/2. Now, this first 10 here is really 10 to the first power. They just don't write it. So the question is, if you have this for exponents, what do you do to the exponents? You add them. This would become 1 1/2 or 3 halves over there. So 10 to some power equals 10 to the 3 halves. Therefore, what is my x value equal? The number 3 halves is the answer.